So, a mate of mine asked me if I could do a bit of 3D printing for him. He's got an off-road racer and he wanted to install a Cartek switch control panel into the air intake above his head. Well, it's not above his head, but it's alongside him. So he gave me the actual unit itself and I started to CAD it up. I always start in this kind of situation with the component that's going to be fitting into what I make. So basic dimensions taken, CADing it, importing all the dimensions, screw holes, and then I'll obviously give it some depth and body because it's got a switch unit and also it's got an electrical connector on the back. Now Rob needed it as high as possible, and the top and bottom of this Cartek unit has got quite a gap on it. So when I was CADing it up, we had to try and lose as much of that into the air ducting as possible. And in the air duct it's susceptible to water, so the cap that goes over the top of this had to be a watertight top as well. So as you can see, I'm getting the basic size of the unit and we're just adding in the features to the back of it. So the unit needed to be sit at a bit of an angle, and then we calculated a rough angle and curved it just to give it some appeal. I could have had it flat, but the curve looked a bit better. And it was also a matter, and you can see here at the top, the unit protrudes up into the space of the air duct. Once I've got it all fitted up, I recessed some fitting holes because I wanted to make some little aluminium fixings just to spread the load a bit when it's fitted up. And you can see here how it fits into the lower part of the housing. Now Rob was going to paint this. He runs a body shop, a car body shop, so finishing it off is not a problem. So here I am designing the top cover. Now this is probably the most crucial part actually, because I didn't want to let it water in, and it needed to be reasonably strong and have some connectors. Rob put some wiring glands on the side, but this top bit, you say, is potentially exposed to water ingress. So these are the various parts. The green and obviously the yellow bits, the only bits that I printed off. And they just sandwich between a layer of aluminium, and the yellow bit is the cap that goes inside the air vent. The air vent, by the way, is for a rear radiator because it's rear engined and rear cooled. Yes, this is just a bit of scrap aluminium. I'll keep a few bits and pieces as about. It's not particularly of any use. I wouldn't use it for anything structural, that's right, because it's not great aluminium. But rather than just scrap it, I just keep a couple of bits and pieces kicking about. Now I'm using a high-speed steel bit here, and I've got two of these, and this has just happened to be the one that was in my tool holder, so it's got a sharp edge. The other one's got a radius on the end of it, which probably would have been better for doing this, but I mean, it was in the tool holder, so I used it. It's quite good at hogging off decent bits of material. It does actually manage to break most of the chips on aluminium, and you'll see that in a second. So this part is going to be a hexagon nut which is going to insert into the little hexagon bosses, and it was basically just to spread the load. I could have used a washer or something like that, but I felt this would be a better idea.
Let's be greedy and go for 4 and see what happens. I might put a dab of oil on it to see if that makes it better. Okay, so I have got it set up in the mill, and I'm just going to basically, I've got a nice large end mill in there, as you can see. I'm going to take a larger cut as possible. I'm just going to start off with 1 mil, turn it over, take another mil, because total cut, I believe, needs to be 2.7 mil off this. Not entirely sure if that's correct or not, but that's what the figures say. To me, it doesn't sound enough, but there you go. Feeding it across lightly because it's a large cutter. Last thing we'll do is just shift the whole lot. Shouldn't do. Not touching anything. There we are. So 17 mil. I want 16 mil. So simply another half mil off each side. So I'm back in the lathe and I've got my part in the chuck's out of gear so I can spin it by hand, and I've got an M4 tap. It's a starter tap. I might change that to a bottoming tap actually, well, after I've started anyway. So I'm just going to thread this by hand like so. I want 5 mil, thereabouts anyway. That's close enough. to make sure they're bang out right, because I don't think they're going to go in if they cock. There we go, in. I'm just going to put a screw in there just to make sure. I'll leave the screw in there anyway.
So in this picture the two parts are sitting together, but of course they're upside down, and you can see how much the lower part will sit into the top part, the cap. Now that's not a very clear picture, but that's through the windscreen of the unit fitted in, and that's from the inside. And you can see the top screws, you can't actually be seen, they actually protrude up into the top. Now Rob runs a car body shop, and he actually ran a bit of filler over it and painted it. Now when Rob installed this, he was actually doing a refurb of the vehicle, so which he does on a quite regular basis, and the roof wasn't in place, so it was easy for him to do and very difficult to show the cap on the top of the electrics. So I'm going to leave you some pictures with Rob in competition in its various paint disguises.